Right, let's have a look at number 5 here. So we've been given a sketch of the part of curve C with parametric equations given to us. The curve crosses the y-axis at point A, as we can see, and the x-axis at point B. We've been asked to show that A has coordinates 0, 3. So let's write this down. X equals 1 minus a half t, and y equals 2 to the t minus 1. Now at A, we know that your y coordinate is, well, we don't know what your y coordinate is. We know x equals 0. We don't actually know what the y coordinate is. So what we can do is substitute that into this equation and work out a t value. So 0 equals 1 minus a half t. We get a half t equals 1. We get t equals 2. And then what we can do to find the y coordinate, we can substitute y into this equation. And so we get y equals 2 to the power of 2 minus 1, which equals 3. And therefore, A has coordinates 0, 3. Similarly, for part B, we know B has a y coordinate of 0 and we don't know the x coordinate. So we're now going to use y to find our t value. 0 equals 2 to the t minus 1. We've got 1 equals 2 to the t, and therefore we get t equals 2 to the power of 0 equals 1, so t must be 0. Now once we know t equals 0, we can work out the x coordinate. X equals 1 minus a half times by 0, which is 1. So B therefore has coordinates 1, 0. Now for part C, we need to find an equation to the normal to C at the point A. For these type of questions, I always sort of like sketching them so that I know roughly what it is that I'm trying to work out. So this here would roughly be the tangent, the solid black line, straight line. But we want the normal. Maybe that's not 90 degrees, but maybe something like that. And it was at A, which is here, the y-intercept. Here's the normal. So this is the question mark that we are trying to work out. Now, a straight line has an equation y equals mx plus c. To work out, or any of the other forms, to work out the equation of a straight line, we need a pair of coordinates, which we have, but we also need the gradient, which we don't have. So the first thing we're going to have to work out is the gradient of the tangent. So dy by dx for parametric equations is dy by dt divided by dx by dt. So that then means that we need to differentiate x and y. So dx by dt equals minus a half, and dy by dt, if we differentiate 2 to the power of t, we should remember this, one of those rare ones, but when it does come up, throws most people off. 2 to the power t ln 2. And when we differentiate 1, we get nothing. So therefore, the gradient of the tangent, which is given by dy by dx, is going to be 2 to the power t ln 2 over minus a half. And therefore, I can say m of tangent equals, we worked out the t value for a earlier, and t was equal to 2, so we can substitute that in now. 2 to the power 2 ln 2 over minus a half. 4 over minus a half is going to be minus 8 ln 2. And therefore, m of normal is going to become the negative reciprocal of that, which is 1 over 8 ln 2. So now we have the gradient of the normal. We know that it passes through 0, 3. We can use the equation for line y minus 3 equals m, which was 1 over 8 ln 2 times by x minus 0. And we can leave it like that because the question hasn't asked us to leave it in any particular form. So that's part C done. Now part D, we have been asked to work out that region R. If we think about region R, that sort of starts at x equals, well, it's between x equals 1 and minus 1. But we should remember, for parametric integration, the formula is y dx by dt. Now, how are we going to do this? Now, these aren't our t limits, but they need to be t limits because we're integrating with respect to t. So how will we do that? Right, so we were trying to work out t values. We know the t value at x equals 1 because we worked it out earlier. And let me just scroll up to that and find it. So t was 0, that's right. So we've got t equals 0 here. Now, we know x equals minus 1, so minus 1 equals 1 minus a half t. So we get 2 equals a half t, and t equals 4. So we've got t equals 4. Now y is 2 to the power t minus 1. Dx by dt is minus a half. And then we've got dt here. Now what we notice here is the limits are the wrong way around. So we need to put them the right way around. And in doing so, we need to multiply our integral by minus 1. If I multiply the integral by minus 1, it's the same as changing this negative a half to positive a half. So I'm going to say half times by 2 to the t minus 1 dt. Now, what we can do is take the half out, integrate 2 to the t minus 1 dt between limits of t equals 4 and t equals 0. Now, integral of 2 to the power x, again, very rare, but when it does come up, most people get that wrong. Integral of a to the power of x dx equals a to the power of x over ln a. So in this case, it's going to be 2 to the power of t over ln 2 minus t between the limits of 4 and 0. So let's now try and work that out. 2 to the power of 4 is 16. 16 over ln 2, take away 4. Take away 2 to the power of 0 is 1. We get 1 over ln 2. So we can then simplify this. We can collect the ln2s. The denominators are the same, so we can subtract the numerators. We get 15 over ln2 minus 4. And we can leave it like that. It's the exact value, or we can multiply the half in there. Okay, so that answers this question here.